Okay, here we are doing the calculations for the boiling point elevation lab. Okay, so here's what we need to do. Calculation 1, delta T, that temperature change after you added the Na2SO4. Number 2, how many moles? You have grams, you're going to convert those to moles. Next, we want what's the temperature change per mole. So take your answer to number 1 divided by your answer to number 2. Question 4, what's the mass of the solvent used? Okay, and they say you can do it 2 ways. We can just figure it out, the mass of the water, but calculate from the mass of the salt that was left at the end of the experiment. Number 5, molality. Let's remember the units. That'll help us with number 5. And then delta T for number 6, the temperature change per molal. So that will give us that constant. And again, the magic number we're looking for is listed in number 7, 0.512 degree Celsius per little m, per molal of particles. All right? So if that makes all sense to you, just move on and do those calculations. I'm just going to use some, remind you of a few things. Again, in molality, okay, molarity, big M, is moles of solute per liter of solution. That's what you're so used to working with, okay? But here, little m, molality is going to be equal to moles of solute per kilogram. And again, that's what we learned on page 266. Okay, calculation 1 then says calculate the temperature change. And again, this just would be delta T from our work on the previous slide. Says take the boiling point of your solution. Take the boiling point of the solution. So that would have been step 1. Minus the boiling point of your pure solvent. That means just the water alone. So that was your first delta, that was your first temperature. And then you boiled again after you had added the salt, therefore you had a solution. So, simple delta T calculation. Okay? Calculation 2. Calculation 2. Okay? Calculation 2 says, let me get my screen up just so you don't jump ahead, says change those grams to moles. You were all supposed to start with 10 point something grams of Na2SO4, so change that to moles. We're all of Na2SO4. So of course I need a box. This is going to be grams per mole. And what you're going to do is take 1 mole of sodium sulfate is 142.05 grams of sodium sulfate. I know it's hard to read that number. Let me write it again. 142.05 grams. Okay? And we should all be somewhere in the neighborhood of 0.0704. Don't forget, you need quite a few sig figs as we do our work here. But we're all going to be in that neighborhood. Okay, so that was calculation 2. Calculation 3. Calculation 3 says, take what is delta T per mole? We'll take your answer to number 1 divided by your answer to number 2. Because you calculated moles of Na2SO4 in number 2, and you calculated delta T. Okay. Number 4, what we need for calculation 4? It says, what's the mass of your water used? What's the mass of the water, the solvent used? So that's where I need you to peek at what was your volume. And it says calculate from the mass of the salt water at the end of the experiment. Okay? Because you know what it was before you added the salt. And then now, if you take the mass at the end, you should be able to calculate that. Okay, so 4, all I say is at the end. And so follow that calculation. Hopefully you took some work with that. Now number 5 is the key. Number 5 is little m, which is, it says calculate molality. One more time, let's get our labels. Moles per kilogram. So basically you're taking your answer to number 2. Okay. And then you're changing your mass of water here from number 4 to kilograms. 0.0704 moles per 50 grams. Was it 50? Was it 48? Only you know. This is not good data, what I have right here. And so again, if I had 50 grams, change those to kilograms. Mine came out somewhere in the neighborhood of 1.41 moles per kilogram. Questions? I'm doing number calculation 6 now. What is the temperature change per molal? The temperature change per molal. So take your answer to number 1 and divide it by your answer to number 5. And what will our label be? Well, it'll be degrees Celsius over moles per kilogram. It's a double label there in your denominator. Where do you get molality? From number 5. So that's where that number will go. Okay, for 6. Right? So that's the magic number. Whatever you get when you finish this calculation will be degrees Celsius per molal. And according to number 7 here, okay, according to number 7, that answer should be 0.512 degrees Celsius per molal. All right? So that's what we need you to do for number 7 is calculate that percent air. How are you going to finish this lab write-up? Okay, how are we going to finish? You need to do a reflection. And in a reflection, restate purposes. And again, there should be at least 3. You thought this was an easy, sneezy lab, right? Boiling water, add some salt, boil again. So give me 3 purposes. I'm hoping that you talk about molality as being something new that you did. No need for the percent air. You do that in number 7. So it's the same as number 7 in our work there. But discuss that percent air. Really? How? If you're discuss if it's greater than 10%. If you're over 10%, I need to know what happened. Okay? And then suggestions for improvement. Okay? Once you're done with that, please, I am going to be collecting this lab manual soon, and that's why I'd like you to get all these written up, and this lab written up, and I think it's pretty straightforward, other than sometimes there's a big error. Let's try to hopefully we kept that down today. All right, have a good day.